All right, welcome viewers. Today we want to do our design of our bridge design, and so I'm going to start by uh, activating the B valve in Start Pro. So just click the B valve from this icon. The next, I'm going to open a file, and you can input the file name, whatever name of your choice. Just fix the file name. Okay. So we have other files. So once we've done that, rating the file name, we can go straight to Start Pro Windows. Okay, let's click that of space. We'll say add, and here we come. All right, so once we've opened the windows, we can remember that our bridge is 11 meters by 20 meters. So I'm going to start by placing a node. I place a node, and then I'll do a translational repeat in the Z direction. uh, 11 meters, and I'll say link. Okay. All right. So I've gotten my width of my bridge, which is 11 meters. You can see it. Let me zoom it a little. Uh, we need to establish the end and the start of the beam. We have this end. The green portion is the start. The blue portion is the end. So what we're going to do, remember that our bridge is, we have cantilever of 0.6. So I'm going to impute that value, 0.6. I'll say add. Okay. So I'll add. I'll also do a similar thing for the other side of the bridge, another 0.5. So now we've gotten 0.6. So we'll be left with 9.8. So by the time we minus 0. Okay, minus another 0.6 on the right hand side. So let's just pick our 9.8, which is the space between the two cantilevers. Okay, so I've created two knots, 0.6 on both sides. So now I would like to uh, we can do a translational repeat by for 20 meters if we like, or alternatively we can just decide to create the node for the remaining beams. It's assumed now that we have two beams, one at the distance of 0.6 from the left hand side and 0.6 from the right hand side. So whichever side you wish, you can work on that. So I've done my translational repeat, so I now have those beams. Okay, so I will create the additional three beams. I already have two at the extreme ends by inserting nodes. So I'm going to create my beam has space 2.45 meters center to center. So I'm going to be left, since I'm using total of 5 beams, I will be left with 3 beams since I already have 2. So I say add, number of beams, add. So you can see it. You say okay. All right. So I've established that. I'll do the same for the second one. Let me introduce the beams, 3 beams. 3 nodes, I mean. So we just add the 3 nodes. So 2.45. So we say add and okay. Now I've done that, I will quickly draw my beams, create new beams. All these beams I'm creating represent my longitudinal beams. So I'm going to create it here. Take it here. All right. So I've created a total of 5 longitudinal beams. Okay. All right. So uh, remember that the 5 beam is excluding the 2 beams at the extreme. So those ones, we are going to remove them. So I'm already placing my my slabs. I'm placing my slabs, my deck slabs. So I'm going to fix the deck slab for each of those panels. Okay. I'll fix, draw it here, drag it, and drop it. I'll do the same for this point. I drop it here, and I drop it. All right. So, and similarly, I'll do the last for the small panel. Okay. Okay. So, having done this, the next thing we are going to do is to generate mesh for this particular structure. Of course, the two extreme beams at the cantilever edge, I'll delete it in later on. I'll delete it. We can leave it as an upstand beam. It could stand as a parallel beam, but in this case, I would like to delete it. So let's look at the properties of the beams. We'll look at it. So we want to generate mesh. We know that the longitudinal direction we have 20 meters. The transverse direction we have 0.6 and we have 2.45. So we need to create a kind of plate that is very, very realistic. If we decide to pick a plate of 0.5 in the longitudinal direction, it means we are going to divide the 20 meter by 40 to give us 0.5 meter for the longitudinal direction. Similarly, if we want to get that of the transverse direction, we will have to choose a value that is also reasonable and will be easy to assess in terms of results. So for me, I think the least plate we have there for the transverse direction is 0.6. And if we have a plate, if we have a 5 division of plate, I think that will be okay. That will give us about 0.129 or so. Okay. So if you look at it now, you can see it. You see the division. You see the divisions. So remember that CD represent our 20 meter, while AB also represent our 20 meters. So we know where to fix our values. Okay. So that is what we're going to do. So I think we'll start with the longitudinal direction to be 40. So that we'll have 0.5 for each side. While the transverse direction, we can do it as 5. So that for the small portion of 0.6, we'll have 0.12, while the big portion will have our value. I think we'll have about 5 out of that also. So I'm going to do that now. I'll go to generate a mesh. Go to generate mesh. But before I do that, let me define the property which I'm doing. I'm going to define this. I'm creating a column. So let me put a circular column. Create it here. Add a value for that column. I just want to finish up with the model before we do generate mesh. Okay. So I'm working on that now. Add the longitudinal beams added, as well as the transverse beam, which represent our pier cap beam. I'm going to add it. So have that figure. We'll add. Okay. We've also not added the plate. We need to assign the plate. So we'll add the plate. So now that we have done, let's assign properties or look for beams parallel to the z-axis, which is our pier cap. So we assign it. Beam parallel to the x-axis, which are longitudinal beams, we will also assign, say assign yes. Okay. And the last one is going to be our column, which we are going to pick a distance. These are just a choice, so you have to know what kind of bridge you want to design. Where do you want to put your piers? How many piers you intend to use? For me, I'm going to be using 2 piers. So I'll put it at the middle of this panel of so I say okay, I've created a node. I'll do the same at the middle, put it at the portion of 0.5, which is the middle. I'll say 0.5, then I will say add, then is okay. Okay, so I've done that for one side. I'm going to repeat the same for the other side. Okay. Okay, so I've done that for the other side. So it's now to assign, create my, now for me to create my peers. So I'm going to highlight the node while I do uh, translational repeat with in the y direction. So let's call it peer to be 5 meters, and I'm going to translate repeat, and I will link it. So I say okay. Now I have, unfortunately, the one on this side is like we didn't create the node, so let me just create the node, or create the node 0.5. Okay, add. Okay, so I can highlight it with the node cursor. I can go for my translation and repeat and link 5 meters, -5 meters. So I say okay. All right, so now we have our columns, our peers, bridge peers. So we can, all right, so creating a support, we can use pin support for all of them. Let's just call all of them pin. So assign pin support. All right, it's okay. So now that we've created our support, the structure is good to go. But when we look at it from the 3D view, we see this. You can see, zooming it now, you can see that we have beams that are projecting above our slab. So, and that is not what we actually wanted to see. So firstly, let's assign our column properties. Once we've assigned it, we'll work on that projection. All right. Okay. So let's go and look at it again. Now our column is already there. We still have those beams projecting above the slab. So we are going to ensure that the beams are seated on the pier cap. So we go first of all by working on that. But for us to work on that, I think we need to create our mesh. We'll highlight this entire structure using our geometric cursor so that we can create our mesh. I've already told you what the size of the mesh we intend to use is. And the reason why we are choosing that for easy reading, and it will also give us more realistic values. So we are using uh, that size of mesh, 0.5 on the horizontal or longitudinal direction. We have 0.49, which is for the 2.45 bay, while for that of the 0.6, I think we have a 0.129 or so. All right, so we want to create that mesh. Let's work it out. Let's create the mesh. The long side of the mesh represent our AB, while the long side, the longitudinal direction of our bridge represent AB in our mesh generation um model menu, or our mesh generation menu. You can see the long side represent our AB, and the shorter side of our bridge represent our, or represent other letters you can see here. So here I'm going to put, I'm going to generate mesh. Instead of 10 that is at the default, we're gonna make here 5, and we're gonna make here, we need 40 of such. We need 40. Okay, so that we can have 0.5 on the longitudinal direction, while we need 5 that we can have 0.49 for the 2.45 direction. So let's say quadrilateral mesh. All right. Yes, our mesh has been created. So we've created our mesh. So we intend to uh, run it. Let's see it in 3D. You can see the mesh has been generated. Let's take a closer look at the model. All right. Now you see we still have the problem of the beam projecting above the slab, which we do not really want. So we're going to work on that. We're going to work on that. All right, so we're going to offset by working on that. We're going to offset our beam and bring it down. So I go to specification icon and I go to member specification. So all right, so before we continue, let's fix our plate. All right, so let's fix our plate thickness 0.25. So we've done that, and we can assign that value to the structure. Okay. All right. So having done this, we can now offset. Now our distance, we want a case whereby our beam is going to be below, our longitudinal beam will be below our deck. And for us to achieve that, now that we have our beam to be 1.2 meter deep, we have our slab to be 0.25. What it means is for us to go below our slab, we need to have half of our beam depth plus half of our slab depth. Okay, and that is 0.6 plus 0.125. That will give us 0.725. So we're going to offset our beam by 0.725. So I go to offset. So once you highlight the beam, you can see the release at start and release at end. You can open and see all these icons. So you can see offset. You can say you go to start, the starting point of your beam. You face the value and the direction you intend to offset. Uh, Once that is done, once that is done, we can go ahead to highlight our beam so that we can assign the property we've just finished. Okay, so I've highlighted my longitudinal beam, so I want to assign the property. Now you see that I've just assigned the start point, so I'll assign the end. So by the time I assign the end, the beam is now fully uh, offset from its original position. We can decide to view it on 3D window to look at it. Uh, we can look at it. Let's see from the top plan. Now I want to remove my edge beam. I think I don't want that edge beam. I want to remove it. So let me highlight it. All right, so I'll go to, let me view it. I'm going to view it separately so that I can easily delete it. Gonna view it, so I'll delete it from this point. All right, so delete. Okay, so let's go. So I think we can now say bye bye to that beam. All right. Okay, so now I've deleted it. So now in my cantilever slab, I'm not having any beam at the two edges, so it is free, made up of just slab. I don't want to put a beam. All right, so looking at the 3D now, you can see the zoom. Our peer cap beam is still above, so I will need to offset it so that it goes below our longitudinal beam. Okay, so I'm going to work that out. You can see it. You can see it from this angle. Okay, so let's go ahead with that. All right, so going ahead with offsetting it, we'll click our member specification, and we'll go to beam specification, and we'll move straight to offset. All right, so I've offset 1.45 and assign it to our peer cap beam. Uh, so we've gotten that. So you can see the 3D view of it. We'll have the 3D view. Okay. So now we've been able to establish the various uh, elements of this bridge. Looking carefully, you see that everything is ready. So the next step we are going to take is to run the analysis of this structure to be sure that everything is in order before we apply our live load. So we need to run this analysis to check, do perform analysis to check whether the structure is in okay. All right, so you can see that we have zero errors in that reaction. So these are the output from the analysis we've just conducted. You can scroll down and look at it. You can look at the load. You can look at the reaction, support reaction. We can look at the stresses in this structure, look at the support reaction due to self-weight of the beam and the slab. We have that already. So having gotten this, the next thing we would like to do is to apply our live load on it. And that is where we have our beaver coming into play. We've seen all the reactions, so we are going to activate our beaver, or we go straight to the bridge deck. All right, so we can as well look at other output like the bending moment. Let's be sure that what we have for bending moment is equally okay, bending moment diagram. So I'm going to look at that bending moment diagram shortly. If we open the bending moment diagram, you discover that we're going to have bending moment at the edge, which is not actually the real picture of this beam. The moment at the edge should be zero because the reaction is going to be transferred to the peer cap as point load. So we're going to have the reactions at point load. So, but now you can see that we have moment at the end, which is not what we have. So we're going to release moment at that point so that we can have the real picture of the situation. Okay. All right. So we're going to look at how we can do that in our next class. So please do wait to join us up in our next class. Have a wonderful time and stay blessed.